You think light travels. You think photons race through space at 186,000 miles per second, carrying information from distant stars to your eyes across billions of years. You think light moves from the sun to Earth in 8 minutes from your phone screen to your retina in microseconds? But you're completely wrong. Light doesn't travel. Light has never moved anywhere ever. What you call the speed of light is actually the speed at which space itself updates information, not the speed at which anything travels through space. Understanding this completely overturns everything you thought you knew about physics, time, space, and the fundamental nature of reality itself. The evidence for this isn't hidden in classified research or theoretical speculation. It's sitting right in front of physicists, hidden in plain sight within the equations that govern electromagnetic radiation and quantum mechanics. But the implications are so profound that most scientists can't see what their own mathematics is telling them. Light doesn't move because movement requires time, and time doesn't exist independently of information processing. What we call time is actually the rate at which the universe updates its information states. Light doesn't travel through this process. Light is this process. When you think you see light traveling from a source to your eye, you're not witnessing movement through space. You're witnessing the sequential updating of spatial information states across the electromagnetic field that connects all points in space instantaneously. The confusion comes from thinking about light as particles or waves moving through empty space. But space isn't empty, and light isn't separate from space. Light is the mechanism by which space itself maintains information coherence across distance. Every point in space is connected to every other point through electromagnetic fields that exist everywhere simultaneously. When we say light travels from point A to point B, what's actually happening is that the electromagnetic field is updating its information state in a sequence that creates the appearance of movement. But this updating doesn't involve anything actually moving. It's more like a wave passing through water. The wave appears to move, but the water molecules just oscillate up and down in place. Except with light, there's nothing even oscillating. There's just information state changes occurring in sequence across a field that exists everywhere at once. This explains why light always appears to travel at the same speed, regardless of the motion of the source or observer. It's not that light has a fixed velocity through space. It's that space updates its information states at a fixed rate, and this rate is what we measure as the speed of light. Einstein's relativity doesn't describe objects moving through space-time. It describes how information propagates through the interconnected electromagnetic field structure that constitutes space itself. The speed of light is the processing speed of reality. Think of the universe as a vast computational system processing information about its own states. What you call light is the transfer of information between different processing nodes in this cosmic computer. The speed of light is actually the clock speed of the universe's information processing system. This is why light behaves so strangely compared to ordinary moving objects. Light doesn't have mass because it isn't a thing moving through space. It's the process by which space updates information about energy and matter distributions. Light doesn't experience time because light is the mechanism by which time gets created through information state changes. When physicists discovered that light has both wave and particle properties, they were discovering that light is neither waves nor particles moving through space, but information processing events occurring within the electromagnetic field structure of space itself. The wave properties of light represent the field-based nature of information propagation. The particle properties represent the discrete, quantized nature of information processing events. Light exhibits both properties because it's the fundamental process by which the universe maintains and updates information about itself. But this raises a profound question. If light doesn't travel, how does information get from distant stars to Earth? How do we see things that are supposedly billions of light years away? The answer reveals something shocking about the nature of space and distance. Distance isn't what you think it is. What we call distance is actually a measure of information processing complexity rather than physical separation. When astronomers say a star is a billion light years away, they're not describing how far light had to travel. They're describing how many information processing cycles are required for the electromagnetic field to maintain coherence between Earth and that star. Space doesn't separate objects. Space connects them through electromagnetic field interactions. What we interpret as distance is actually the complexity of these field interactions, measured in terms of information processing requirements. This explains why quantum entanglement can create instantaneous correlations between particles regardless of distance. There is no distance in the conventional sense. There are only different levels of information processing complexity required to maintain field coherence between different regions of the universal electromagnetic field. When you look at a star, you're not seeing light that traveled billions of years to reach you. You're accessing the electromagnetic field information state that represents the energy configuration at that stellar location. The time it takes for this information to reach you is actually the processing time required for your local electromagnetic field state to access and decode information from a distant field configuration. This is why the speed of light appears constant in all reference frames. It's not that light travels at a fixed speed. It's that information processing within the electromagnetic field occurs at a fixed rate that defines the structure of space and time itself. But if light doesn't move, this completely changes our understanding of causality and the relationship between cause and effect. If information doesn't travel from place to place, how do events in one location influence events in another location? The answer is that cause and effect don't operate through influence traveling between separate locations. Cause and effect occur through coordinated information state changes across the interconnected electromagnetic field that constitutes space. When you flip a light switch, you're not sending electricity through wires that then makes a bulb glow. You're creating a change in the local electromagnetic field state that triggers coordinated field state changes throughout the connected circuit system. The flow of electricity is actually synchronized field state updating across the entire circuit instantaneously. The appearance of electrical current flowing from the switch to the bulb is similar to the appearance of light traveling from source to destination. It's an interpretation of sequential information state changes rather than actual movement of anything through space. This explains why electrical systems respond instantaneously when you flip a switch, despite the fact that individual electrons supposedly move quite slowly through conductors. The system responds instantly because the electromagnetic field coordination is instantaneous. No actual particles need to travel from the switch to the bulb. The same principle applies to all electromagnetic phenomena. Radio waves don't travel from transmitters to receivers. Radio systems create coordinated field state changes that allow information sharing across distance without anything moving between locations. When you use a cell phone, information doesn't travel through the air from your phone to a tower. Instead, your phone creates specific electromagnetic field state changes that coordinate with complementary field state changes in the cell tower system. The signal exists in the coordinated relationship between field states, not in anything moving through space. This field coordination happens instantaneously regardless of distance, but the information processing required to decode and respond to field state changes takes time. This processing time is what we interpret as signal propagation delay. Understanding that light doesn't move also resolves many puzzles in quantum mechanics and relativity that have confused physicists for over a century. The wave-particle duality makes perfect sense when you realize that light is neither wave nor particle, but information processing events in the electromagnetic field. The measurement problem in quantum mechanics dissolves when you understand that measurement isn't detecting pre-existing particle properties, but triggering field state changes that create the properties being measured. Einstein's spooky action at a distance isn't spooky when you realize there is no distance in the conventional sense. There are only different information processing complexities within a unified electromagnetic field system. The apparent paradoxes of relativity, time dilation, length contraction, mass energy equivalence, all become clear when you understand that these effects describe how information processing rates change under different field conditions rather than how objects behave while moving through space. Mass doesn't increase with velocity because objects don't actually move through space. What we call mass energy equivalence describes how much information processing is required to maintain different field configurations. Higher energy configurations require more processing resources, which we interpret as increased mass. Time dilation occurs because information processing rates change under different electromagnetic field conditions. Clocks don't slow down because time is relative. Clocks slow down because they're information processing devices operating in field conditions that affect processing efficiency. But perhaps the most profound implication of understanding that light doesn't move concerns the nature of consciousness and observation. If light is the information processing mechanism of the universe, then consciousness might be the universe's way of accessing and interpreting its own information processing. When you see light, you're not detecting something that traveled to your location. You're accessing the information processing activity of the electromagnetic field itself. Your visual system isn't receiving light signals from external objects. Your visual system is interfacing with the electromagnetic field information processing that represents energy and matter configurations throughout space. What you call seeing is actually the universe knowing itself through conscious field interfaces. This suggests that consciousness isn't separate from physical reality, but is the means by which the universe's information processing becomes self-aware. You're not an isolated observer watching light arrive from distant sources. You're a localized interface through which the universe's field information processing accesses and interprets itself. This explains why quantum mechanics requires conscious observation to collapse wave functions into definite states. Consciousness isn't just passively observing quantum systems. Consciousness is the mechanism by which the universe's information processing creates definite field configurations from quantum possibilities. When you observe a quantum system, you're not just gathering information about pre-existing properties. You're participating in the information processing that creates those properties by interfacing with the electromagnetic field in ways that trigger specific field state changes. But recognizing that light doesn't move also has practical implications for how we understand and work with electromagnetic technologies. Current electrical and communications technologies are based on the assumption that electricity and radio waves move through space at finite speeds. But if electromagnetic phenomena actually involve instantaneous field coordination with information processing delays, then entirely different technological approaches become possible. Instead of trying to send signals faster through space, we could focus on developing more efficient information processing interfaces with the electromagnetic field. Instead of moving electricity through wires, we could develop technologies that interface more directly with field state coordination. Some researchers are already exploring technologies based on field effects rather than particle movement. Zero-point energy research, scalar wave technologies, and certain quantum communication systems may be unconsciously working with field coordination principles rather than conventional electromagnetic propagation. Understanding the true nature of light could revolutionize technology by shifting focus from moving things through space to optimizing information processing interfaces with the universal electromagnetic field system. But this understanding also raises profound questions about the nature of space, time, and physical reality itself. If light doesn't move and distance is just information processing complexity, then space isn't what we think it is. Space might not be a container in which objects exist. Space might be the information processing relationships between different field configurations. Time might not be the dimension through which events unfold. Time might be the sequence of information processing states through which the universe maintains and updates its field configurations. Matter and energy might not be substances that exist in space and time. They might be stable patterns in the universe's information processing activity that create the appearance of substantial objects existing in space and time. From this perspective, the entire physical universe is an information processing system of staggering complexity, creating the experience of space, time, matter, and energy through coordinated field state changes. What we call physical reality is actually computational reality. The universe computing its own existence through electromagnetic field information processing. This doesn't make reality less real or reduce consciousness to mere computation. Instead, it reveals computation and consciousness to be more fundamental and more remarkable than previously understood. The universe isn't just a collection of objects in space. It's a self-aware information processing system creating the experience of space, time, and objects through its own computational activity. You're not just living in the universe. You're participating in the universe's ongoing self-computation through consciousness interfacing with electromagnetic field information processing. Every moment of experience represents the universe knowing itself through conscious field interaction. Light doesn't travel because light is the universe's way of maintaining information coherence across the field structure that creates the appearance of space and time. Understanding this transforms light from a mysterious phenomenon that somehow travels at a fixed speed to the fundamental process by which reality maintains and updates itself. When you see light, you're not witnessing movement through space. You're witnessing the universe's information processing in action, creating the space and time in which movement appears to occur. And consciousness is how the universe experiences its own information processing activity from the inside. Light doesn't move, but reality moves through light, through the information processing activity that creates space, time, and the conscious experience of existence itself.